Today we will start with joint density function for continuous random variable x and y. Okay. The function f of x comma y is a joint density function joint means for two variables of continuous random variable x and y. Since it is continuous, instead of sum we use integral notation. We have two variables, we have to use double integral notations. So first, the f value at each x and y has to be non-negative for all x, y order pair. Second, the range of x is real number and range of y is also real number. So it's double integration, one with respect to x and one with respect to y. This has to be one always, the total probability. And if somebody wants to calculate the probability of all those xy in the region A, it should be always double integration over that region A, f of x comma y dx dy. And you can continue for three variable, four variable, and so on. That many times we have to integrate. One integration is with respect to x and one integration is with respect to y. It depends on nature of the integral with respect to what we want to integrate it. Here, for any region A, in xy plane. So instead of sum, due to continuous random variable, we use the integral notation. Let us have an example on it. A candy company distribute boxes of chocolates with a mixture of creams, toffees, and nuts. Coated in both light and dark chocolate. Coated in both light and dark chocolate for randomly selected box. Let x and y, you read example till then. Let x and y respectively be the proportions of light and dark. Chocolates that are creams. Suppose that joint density function is given by f of x y equal to 2 upon 3 2x plus 3y, when x has this range and when y has the same range, 0 elsewhere. Verify this is 1. Second, find the probability of the random variable in the region A. आवाज लेक्चर चालू दोन येत आता. ओके. Find probability for random variable x, y in A. येतोय आवाज?
हो सर.
Where A is region x, y such that 0 is less than x less than half, 1/4 less than y less than 1/2. So this is the region A. Okay, let me draw xy plane here. So this is the range for x and it is the range for y. And among this x for 0 to 1. Okay, 1 is here, suppose x for 0 to 1. So this is 1, 0, 0, 0, and y from 0 to 1. This is 0, 1 point and 1, 1 point. So in this region, okay, this is in this region. What is the value of function? This is the region where function has value given 2/3 2x plus 3y, and elsewhere the function has value 0. So we want to integrate that function in the region only. So this is your region of integration. Elsewhere function has value 0 and 0 has integration 0. So I am going to do integrate over this. So first part, minus infinity to infinity, minus infinity to infinity, f of x comma y dx dy. Okay, limit for x are 0 to 1, limit for y are 0 to 1, and f of xy between this region is 2/3 2x plus 3y dx dy. So in this order we can integrate, or we should remember these are the limits for what. So inner integral is evaluated first. There are rules to evaluate double integration. Anyway, all are constant limits. You can integrate by the order. So it's a natural integration, but you have to think y as a constant while integrating with respect to x. So 2/3 integration of 2x is 2x square upon 2, and integration of 3y is 3y into x. And put limit of this x. While integrating with respect to x, y term will be treated as a constant. So 0 to 1, 2/3 x square plus 3xy. Okay, you should put limit of that x in place of x. So 0 to 1, 2/3, x equal to 1, x equal to 0 becomes 0, plus 3y. When you put lower limit, this term will become 0. Okay. Now integration of
2
this
by
is
5.
one line integral. Huh?
2 by
Hello?
5 आहे सर. 2 by 5 आहे.
2 by
5.
इथे 2/5 आहे का? Okay. Let me check what is given there. Okay, here it should be 2/5. Okay, thank you for the correction. 2/5. 2/5. Yeah. 2/5. 2/5. Okay. The integration 1 plus 3y with respect to y. So 2/5 multiplied by integration of 1 is y, and integration of 3y is 3y square upon 2, and put limit 0 and 1. So 2/5, 1 plus 3/2, that is 5/2. So it should be 1. So double integration for x range and y range of given density function is 1. So that second condition you need to verify. Now next your region is what we have to find integration. You have to integrate that function with respect to what region. X is between, okay, let me change the color now. Okay, red color I will take. X is between 0 and half. Suppose half is here. And y is between 1 by 4 to half. If half is here, then 1 by 4 will be here. So the common of these, so this is y equal to 1 by 2, and this is y equal to 1 by 4. The region in that, this is x equal to 1 by 2, x equal to 0. So x equal to 0 is this, x equal to 1 by 2 is this. So on this region you want to integrate. This is your region of integration. This is the region of integration, and in this region what are the limits? In this region what are the limits? Limits are already given to you. If you see, the limits are x actual limit का है 0 to half, and y actual limit का है 1 by 4 to half. So you have to integrate that function between this region only. So you are integrating only for this region, and this is the part of earlier region. So function has value 2 upon 5 or 2x plus 3y. So B part, the probability of xy in the region A is nothing but double integration of A f of xy dx dy. And you are writing the constant limits, so limits of x you should write first. What are the limits of x? 0 to half. F of xy is 2 upon 5 2x plus 3y. With respect to x, we are going to integrate this first, and then keeping y as a constant while integrating with respect to x. And limits of y are 1 by 4 to half. That's it. Be careful while writing limits. So limits for y are 1 by 4 to 1 upon 2. Now I'm going to integrate this with respect to x, keeping y as a constant. So 2 upon 5, let me take it outside completely. So 2x has integration x square, and 3y has integration 3xy. And put these values in place of x only, because you have integrated with respect to x first. So 2 by 5, 1 by 4 to half. When you put half, it is 1 by 4 or 3 by 2y. Okay. Now this is easy to integrate with respect to y. 2 upon 5, 1 by 4 has integration y by 4, and 3 by 2 y has integration 3 by 4 y square. 1 by 4 to 1 by 2. Okay, put limit upper and lower in place of y. So 1 upon 2 minus 1 by 4 upon 4 plus 3 by 4 into 1 upon 2 square 4, 1 upon 4 square 16. So what this calculations comes up? This has given in the book, answer it as 3 upon 160. This is the probability for all those xy in the region A, all those points in x in the region A, and A is just a small rectangle. These calculations you can check. Okay. Let us also make this as example to understand it. Okay. Example number 7 is of the same type. two random variables. Two random variables have joint density function which is given by f of x comma y is equal to 4xy 0. Okay, x is from 0 to 1 and y is similarly from 0 to 1, and elsewhere. So only on that rectangle 0 1 of x and y function as value 4xy, otherwise in the plane function as value 0. So what is asked? Find the probability of 0 less equal x less equal 3 by 4. Okay, x limits are given directly, and 1 upon 8 less equal y less equal 1 upon 2. Limits are given directly. Second, find the probability where y is greater than x. Let me draw the plane for it. This is xy plane in which 0 0 point, let us have 1 0 point here, the same distance 0 1 point, because x and y have same range. So on this square, it is square actually, all sides are equal. You can find by distance formula what is the distance of it. Distance, everyone has distance 1. Okay, on this region f of xy is defining, that is 4xy. Elsewhere, anywhere in the plane, elsewhere function has value 0. But we are not going to verify the condition 2 of the definition. We are going to calculate the probability for that. So let me draw that in different color, 0 to 3 by 4. Okay, where will 3 by 4? 3 by 4 means 75% of it. So this is half, and this will be the 3 by 4. This point is 3 by 4, and y has value 0. So x has this range. What is the range of y? Y has 1 upon 8. Okay, half is here, 1 by 4 is here, and half of 1 by 4 is 1 by 8 is here. So y has this range. So what is common of these two? Common of these two is this. You can draw two lines. This is line y equal to 1 upon 2. Which will be parallel to the x-axis, and this is line y equal to 1 upon 8. Now for y-axis is nothing but x equal to 0, and this is x equal to 1. Okay. X equal to 3 by 4, sorry, x equal to 3 by 4 is 1. So we have this much region. Okay, I will draw. Okay, you understand this is the region of integration. Okay, forget about this extra part. This is ours. Achudala region. Forget about that extra part. So directly limits are given in the part A. We have to integrate for this x and for this y. That's it. The probability of 0 less than x less than 3 by 4, and what is the range of y? 1 upon 8. 1 upon 8 less than y less than 1 upon 2. This is nothing but if you call this region as A, what is the limit of x? X equal to 0 to 3 by 4. I am writing limits for x. So that means you are integrating this with respect to x, keeping y constant, 4xy. You are integrating this with respect to x. Once you integrate with respect to x, later integrate with respect to y, and limits for y are 1 upon 8 to 1 upon 2. So firstly, integrating with respect to x, create y as a constant. So 4y will be constant. Okay, y has limit 1 upon 8, 1 upon 2. 4y is a constant. Integration of x is x square upon 2. And put limit in place of this. So okay, this becomes 2y. X square, it is 9 by 16 minus 0. So 9 upon 8 we can write. 9 upon 8 is common. Integration of y is y square upon 2, 1 upon 8 to 1 upon 2. So it becomes 9 by 16, y square means 1 by 4, y square means 1 upon 64. So what is value of this? 9 by 16, it should be multiplied by 16, so that can be balanced. So upon 64, 16 minus 1, 15, and these calculations we can do. This is 135, and what about this? This is 2 raised to 4 and 2 raised to 6. 2 raised to 10 it is. So 135 divided by 1024. You can check answers from answers. So whatever answer, the procedure is correct. Now we want to integrate it. This is your square, equal square, and you want to integrate it for y greater than x. So I draw the line y equal to x. So where is y greater than x? Y greater than x is here. Here is y greater than x, and here is y less than x, and on the line y equal to x. So this is your region of integration. Now you have to apply the knowledge of double integration. When one limit is in terms of functions of x, here we need to draw the parallel strips in the region. If you drawing the parallel strip to y-axis, that means it is a limit for y. Okay, I will draw parallel strip to y-axis. This is the procedure to find double integration. You can go for multivariable calculus course. So here y equal to x, because what is the lower end of the strip? That is lower limit of this. And this is what is the equation of y? It has equation y equal to 1. So y equal to 1. Now throughout this region, how this strip rotates? This strip rotates from this point to this point. So what is value of this point? This point value x equal to 0. And what is value of this point? This point value x equal to 1. So limits of y are, okay, x is lower limit and 1 is upper limit. Limits for y is this, and limits for x is 0 to 1. So that whenever you get variable limit, that should be integrated first, and then integrate with respect to this. So here at this stage we have to integrate. So this is your region A, where you are going to integrate. So probability of xy belongs to A is nothing but double integration A f of xy dx dy. Now on this region function is value 4xy, but limit you should write accordingly. So you have drawn strip parallel to axis, so limit for y is x and y is 1. So for x, y is integrated with respect to y because this is limit for y, keeping x constant. And then we integrate with respect to x. And in that region, strip moves from x equal to 0 to x equal to 1. Look at the region. This is the first point of the region at which x has value 0, and this is the last point of region at which x has value 1. So these are the limits for x. How this strip can be rotated? So these strips moving in the region from x equal to 0 to up to here. These are the two population for the strips. These strips, here it becomes like this, here it becomes like this, here it becomes like this, likewise. So strip has lower end throughout this region. Strip has this as a lower end, that is y equal to x, because it is changing, it is not fixed, it is not constant, so y equal to x. But upper end is fixed, that is 1. Strips upper end is fixed, so lower end is the variable. And these strips rotate from x equal to 0 to x equal to 1. So likewise, double integration. You can refer the SMLF to understand these double integrations. Okay. So 0 to 1, x to 1, for x is constant, you are integrating with respect to y first. And after integrating with respect to y, then integrate with respect to x. So 0 to 1, 4x, 4 can be taken out. So integration of y is y square upon 2, x to 1 dx. Okay, these two can be go here. So 2 can be taken out, x. So y square 1 minus x square, we get like this. When you put y equal to 1 and y equal to x. So at last 2, 0 to 1, x minus x cube dx. So 2 multiplied by, okay, I'm writing integration of it, x square upon 2, x raised to 4 upon 4, 0 to 1. Upper limit ठेवल्यावर येईल काहीतरी value, lower limit येईल 0. So 1 upon 2 minus 1 by 4 minus 0 minus 0, lower limit. So this is 1 by 4, 1 by 2 minus 1 by 4 is 1 upon 2 again. Calculations check करा बरोबर लगते हैं. Check these calculations. Should not come 1. Where it goes wrong, just see. X minus x square, x minus x cube. Okay. So what it comes? No, it comes 2, 1 by 2 minus. That's a kind of subtraction.
1 by 4.
Huh? 1 minus 1 by 2. 1 by 2 है ना? Okay, it is 1 upon 2. I thought it can be 1. So this is the 50% region of this. So if you want to find integration of this region, it also comes 1 upon 2. So this is half, total use 1. You can see. Because y equal to x divides into equal parts. So 50% is the probability for that region. One can do for, if y is less than x, if y is less than x like this, if y is less than x is mentioned, then your strip will be here. And strip has limit, y is 0 here, on this x-axis y is 0, and here y is x. So 0 to x we have to integrate. And this strip moves from the region x equal to 0 to x equal to 1. Here value of x is 1. So if, and similarly you get half as this, total is 1. So in this way you can integrate it. So let us have another example. Two random variables. Two random variables have the joint density function. Have joint density function given by f of xy is equal to k into x square plus y squares. Definitely you need to calculate constant k. and the limits of x is this 0 to 2 and limits of y is 1 to 4. And elsewhere in the plane only between this rectangle function is this value. So firstly we need to calculate k. Find k. Once you find k, find the probability of 1 less than x less than 2, 2 less than y less than equal to 3. Find probability of y can be anything. Y has limit minus infinity plus infinity. D. Find probability of x plus y greater than 4. Okay, I will draw this first. Consider this as a straight line for y-axis. This is also straight line for x-axis. Both have this range. And this is the point 0, 0. Okay. So you are given that value of x is between, okay, let's say 0 here, 1 here, and 2 here. So x equal to 0 to 2. On x-axis y point is 0, and on y-axis it is from 1 to 4. Okay, I have to draw more on that. Assume this as a straight line. Okay, 1 is here with same distance, 1 will be here. Y equal to 1 means what is the coordinate? 0, 1. Y equal to 1 and y equal to 4. Okay, 1, 2, 3, 4. 4 will assume here it is 4. Not exactly the measure. Okay, 4 will be here. So draw all 4 lines. This will be definitely a rectangle. All will not have same shape. This at this your function has value k times x square plus y square, and outside of this the function value is 0. Outside of this function value is 0 here, outside anywhere. So on this region you have function defined, not other region. Now what is the limit of this region? Likewise, I said earlier, if you draw a strip parallel to okay, not necessary to always draw strip parallel to x-axis or y-axis. You can draw strip parallel to y-axis, x-axis also. So let us have this strip parallel to x-axis, which gives limits with respect to x, and that means we will be integrating with respect to x first. So what is the lower end of this strip? X equal to, if x equal to pi, 0. And what is upper end of this strip? X equal to 2. So x has this limit, and you are going to integrate with respect to x first. And throughout this region, the strip will move from y equal to 1. Here value of y is 1. Y equal to 1, 1, 2 here, 4. So these are limits. Elsewhere it is 0. So first double integration minus infinity to infinity minus infinity to infinity f of xy dx dy is 1. But you have written this x equal to 0 to 2 and y equal to 1 to 4. So in this region function of this value. You are integrating with respect to x first and then with respect to y. So this is always 1. So let me change the colors, it may not be visible to you. Okay, k is constant, can be taken outside. Y is 1 to 4. You are writing integration of with respect to x keeping y constant. So x square has this integration x cube upon 3, and y square has integration y is constant, so y square is also constant into 1 once integration x. So y square has integration y square x. You are integrating with respect to y. Put limit 0 and 2. So this implies this is going to 1 as per the rule. So k times y from definitely these are the limits for y. Now x equal to 2, that is 2 cube is 8 upon 3, 2y square. When you put lower limit it becomes 0. Now integrate with respect to y. This is going to equal to 1 k. The integration of 8 upon 3 is 8 upon 3 into y plus 2 y cube upon 3. Put limit 1 and 4 in place of y. So k, first we want to write value of k. So 8 upon 3 upper limit minus lower limit, 2 upon 3 upper limit minus lower limit, 4 cube it should be 4 cube and 1 cube. Okay. Can you calculate this? 4 minus 1 is 3, not equal to it implies 3 it cancel plus 2 by 3, 4 cube is 64, 64 minus 1 63, so it should be 1. So what is multiplier k? With the k multiplier k 21, 21 into 2, 42 plus 8. So you must have value of k like this. This is equal to 1. K is 1 upon 50. If you take k equal to 1 upon 50, then your total integration will become 1. Okay. So this is value of k. So your joint function you can mention like this: 1 upon 50 x square plus y square, where x has this region range and y has this range. Elsewhere, everywhere you take 0. So this is your density function. Now we'll complete this problem here. The part B. Part B मध्ये काय करायचं आपल्याला x ची range 1 to 2 आहे. Okay, let me go to the diagram. In the part B, what is the range of x? X goes from 1 to, okay, here it is 1. So x goes from here. Okay, let me change the color. So here it is x equal to 1 and x equal to 2. And here is 2 and 3. Suppose 3 is here and 2 is somewhere here. So this is the region where you want to integrate it. This is your A. And for this region, try to find limit. Okay. You can draw straight parallel to x-axis equal to integrate with respect to x. लिमिट्स दिलेत आपल्याला. लिमिट्स काय त्याचे? x चे लिमिट काय 1 आहे आणि वरचं लिमिट 2 आहे. आणि ही स्ट्रीप कशी मूव्ह होते? y इक्वल टू 2 आणि y इक्वल टू 3. सो 2 to 3. So B part, the probability of 1 less than x less than 2, 2 less than y less than 3. Limits are given directly here. No need to draw stick and all. X has limit 1 to 2 and y has limit 2 to 3. And in that region function has value 1 upon 50 x square plus y square. The inner integral are the limits for variable x. So integrate with respect to x. The inner integral is evaluated first. So they are the limits for x. So you are going to integrate with respect to x first and then y. If you integrate it, you will get required answer. I'll just explain the next. You need to integrate it. The probability of 1 less equal x less equal 2. No condition of y. So x has this 1 to 2. So y, what is y range? Y range is given to you. That is y range is 1 to 4. 1 upon 50 x square plus y square dx and dy. While integrating with respect to x, keep y constant. Why I am taking this 1 upon 4? Actually, y has range minus infinity to plus infinity, but for the function value 1 to 4, we can write function value, otherwise no. So I am skipping that minus infinity to 1 and 4 to infinity. In that region, your function is 0. So integration of 0 will be 0. So what is final range of y is 1 to 4 is there. So you should take that. And last important thing is that your region A is all those xy such that x plus y is greater than 4. So you have to draw this region. So how to draw this line? How one should draw this line? You have to find x and y intersect. On x-axis y is 0. If you take x plus y equal to 4, on x-axis y is 0, definitely x becomes 4. And if you take on y-axis, x is 0, y is 4. So 4, 0 and 0, 4 is the intersecting point. So that line will be drawn. So okay, this is one line, and another line is somewhere here. 4, 0. So you are going to draw the line. The region above here, this whole region. This is the whole region there where you want to integrate. But in that region, function has value here only. In this region, function has value here only. या मध्येच फंक्शनची व्हॅल्यू बाकी ठिकाणी फंक्शनची किंमत काय 0 आहे. Okay. Now I need to draw straight parallel to either x-axis or y-axis. If you want to integrate it with respect to x-axis, draw straight parallel to x-axis, and if you want to integrate with respect to y-axis, draw straight parallel to y-axis. Okay, let me change the color of strip to visualize you. I draw strip parallel to y-axis. What is the lower end of the strip? If you want strip parallel to x-axis, you can draw, but you have to find lower limit of strip means lower limit of y. So this line has equation x plus y equal to 4. So y is 4 minus x. So lower end of the strip is 4 minus x. And what is upper end? Y equal to 4. So these are the limits for y. And this strip moves for here, value of x is 0 and here value of x is 2. So 0 to 2 are the limits for x. So last part, the third part, you need to calculate that d part, probability of x plus y greater than 4, that you are going to calculate. It is 4 minus x has lower end, 4 minus x has lower end, and upper end is 4. Upper end is 4. And you are integrating with respect to x. Oh, sorry, we are integrating with respect to y first. And what are the range of x? X is 0 to 2. So now this we can integrate. Integrate this with respect to y first, keeping x constant, means integration of this is x square y, and integration of y square is y cube upon 3. Put limit of in place of y as 4 and y as a 4 minus x. Finally, it will become function of x, and that can be integrable with respect to x. Just try to compute these values. This will be your exercise 2. Any questions you need to ask, you can ask.